Today we're going to look at the volume of cones. Now, a cone is a solid or hollow object that has a circular base that tapers up to a point. And what we're going to do with this is we're going to first of all look at the formula for the volume of a cone. Now, the volume of a cone can be found in a similar way to the volume of a sphere, however, to the volume of a cylinder. However, what we notice here is that if this were a cylinder, we would be going directly up, and instead we are tapering up, and we're actually cutting away what turns out to be 2/3 of the cylinder on the outside. So we're left with 1/3 of that. So we're going to start first of all with the formula for the volume of a cylinder, which is pi times r squared times the height. This is the volume for a cylinder. And what we're going to do is we're going to multiply that entire thing by 1/3, which is of course the same as dividing it by 3. Now, the first thing we need to do is take our radius, which of course is the distance from the center of a circle to its perimeter. In this case, it's 3. So we have our radius 3 right here, and we're going to plug that in for radius. And we have our height here as well. Our height is 4. Height, of course, is the distance from the base to the top of an object. So our height here is 4. So we've got our height as well. Okay, and we're going to put in our operators and everything else as well. So that's a multiplication. This here is a square, first of all, then the multiplication. We're going to multiply it all times pi, and of course we're going to divide it by 3, or multiply times 1/3 as well. Okay, so let's get on with the calculation. I'm going to start by my first part of my calculation. I'm going to end up moving the pi to the end because there's nothing that I need to do with the pi. Of course, I'm being told that I can give my answer in terms of pi or use 3.14. Using 3.14 involves further calculations, so I'm not going to subject myself to that. Instead, I'm going to just simply calculate it with pi at the end. So 3 squared, of course, is 9. And that I'm going to multiply times 4, of course. And everything else is also part of the calculation. So I've got 1/3 times 9 times 4. Now I notice first of all here in this particular instance that having 1/3 times 9 is actually quite an easy problem, because it's just 9 divided by 3. So that's just 3 times 4 times pi, and 3 times 4 is 12. So I've got 12 pi is the volume of this cone. And of course, when you're submitting your answer, you can either type pi, which automatically gives you this pi symbol, the Greek letter pi, or you can use pi here as well. Pi, of course, being the ratio of the circumference of a circle to its diameter. So it is a central part of calculating any object that has a circle as part of it. So let's move on. Okay, now that we have the formula, we're going to just restate that right at the very beginning. Our volume of a cone is 1/3 times pi times the radius squared times h. Now I don't actually need to plug in all these dot multipliers here. I'm just highlighting this to show you that all of these operations are multiplication operations. In general, when we write the formula, or we write this volume function formula, we don't need to put it in the dot multiplier because multiplication is implied. However, here we go. We have our radius and our height right here. Okay, so starting with the radius squared, 3 times 3 is 9. And that is going to be multiplied times the height. Our height here is 2. We're going to move pi to the very end. and we're going to put 1/3 of all of that. Once again, we see 1/3 times 9. That's a nice easy computation. That's 3 times 2 pi gives us, of course, 6 pi. So these are getting quite easy, I'm sure. And there you